Hello, today we're going to look at horizontal projection from your mechanics syllabus. You need to know your SUVAT equations for this. They are listed on the screen in front of you. By horizontal projection, I mean there will be no angles. You're just simply moving left or right. So I'm not worried about angles between planes and whatnot. Okay, so we're going to look at three examples and how they work. Example 1, a particle is projected horizontally at 25 meters per second from a point 78.4 meters above a horizontal surface. Please note it is projected horizontally. And we're going to start by drawing a little diagram so we understand exactly what's happening. First thing we're going to do is work out the time taken to reach the surface. Here's our distance of 78.4 meters from the horizontal surface. We are projecting horizontally with a speed of 25 meters per second. So think of that little purple dot as the object that's being projected horizontally at a speed of 25 meters per second. What will happen to that is when it's projected horizontally, it will, of course, fall down to the surface under gravity. And then the distance between the point of projection horizontally to the end point, we don't know, so we're going to call it x meters. As such. Now, in order to work out the time taken and the horizontal distance traveled, we consider vertical motion and horizontal motion separately. We do two different sets of SUVAT equations for each part. So if I take vertical motion and I resolve with movement downwards, I'm going to do my SUVAT on that. And separately, I'm going to look at horizontal motion with movement to the right, because obviously the thing is moving right and down. Okay, so we're looking at SUVAT for vertical motion. We have our S, U, V, A, and T. Some of this stuff is obvious from the question. It is going to fall a distance of 78.4. So our vertical distance is 78.4 meters. Our initial speed is 0 because it's being projected horizontally. It's not being projected up or down. So it starts with a vertical speed of 0. Its final speed will be v. I have no idea what it will be. Because it's vertical, it's acting under gravity. So our acceleration downwards is 9.8 meters per second. Particularly that because it's not acting at an angle. If it was acting at an angle, your acceleration may not be 9.8. But we'll come to that in another video. So if we look at our SUVAT equations and use S equals ut plus half at squared, we can work out t from there. So S is 78.4. Since u is 0, we've got 0 plus a half times 9.8 times t squared. It should be fairly easy to work backwards from this to find t. If you do it correctly, you should have t equals 4 seconds. In much the same way, we're now going to look at our horizontal motion and do a SUVAT equation for that as well. So think about what's happening horizontally. Some of the values will be similar, some will be different. T is 4 seconds because we just worked it out. Our horizontal distance is x meters. Our initial horizontal speed is 25, tells us in the question. Our final horizontal speed is v, we don't know what it is. And our acceleration initially is 0. Now, why is the acceleration 0? I hear you ask, and if I don't hear you ask, I should be hearing that. It's 0 because there are no horizontal forces acting on the actual particle. Once it's released, only thing acting on it is gravity to bring it downwards. Essentially, it always starts at 0, unless there are angles involved, but we'll come to that. And again, picking an appropriate SUVAT equation, I again used S equals ut plus half t squared, and you should almost always be using this particular equation. So if we plug our values in, S equals 25 times 4 plus 0, because A is 0. So very straightforward, S is 100 meters. So it takes 4 seconds to hit the ground and travels 100 meters horizontally. So example 2, a particle is projected horizontally with a velocity of 15 meters per second. Horizontally is your key word that tells you there are no angles to worry about in this question. I'm going to call my horizontal distance projected x meters and my vertical distance y meters. I am aware I spent vertical wrong. I just don't care. So I'm going to start with my particle, this little brown dot. Since I'm projecting it horizontally with a velocity of 15, there we go, keep it in the screen. I have a little arrow coming off to show my speed of 15 and taking motion to the right. And there's what will happen. The particle will travel along, will eventually fall to the ground. There's my vertical distance, and this is my horizontal distance. And the first question is to work out exactly what they are. So this is a distance of x meters along the bottom, and up the side is a distance y meters. Always use meters when you're doing your Suvat equations unless specifically told otherwise. And as before, the easiest way to do it is to take two sets of Suvat equations, one for vertical motion, one for horizontal motion. So if I take motion downwards, and I look at S, U, V, A, and T again, there is enough information to work out some of these. I'm taking S is y meters. My initial speed vertically downwards is 0 again. My final speed, I don't know, is V. My acceleration downwards is due to gravity, so that is 9.8 meters per second. And the time is 3 seconds, it tells me in the question. So we're going to use the same Suvat equation we used before. S equals ut plus half at squared. It is almost always this equation. So if we fill in our values, we should have y equals 0, because u is 0, plus a half times 9.8 times 3 squared. And if you round it to the nearest number, hopefully you have y as 44 meters, or thereabouts. So our particle falls vertically a distance of 44 meters. And we're going to work out the horizontal distance the same way. See if you can spot my mistake when I write horizontal here. And we should be taking motion to the right. For some reason, I have drawn a little arrow pointing downwards. That is a mistake on my part, but never mind. So, again, if we fill in our values, we know it takes 3 seconds to travel. As before, we know our acceleration is 0 meters per second, left and right, again, because there are no forces acting on it horizontally, sorry. We know our initial speed is 15. It tells us in the question. And we know our distance traveled horizontally is x meters. And again, pick an appropriate Suvat equation. It is almost always S equals ut plus half at squared. Plug the numbers in, simplify it down. So S this time is x. Our initial speed is 15, our time is 3, and our acceleration is 0. So x is exactly 45 meters. Very straightforward, I hope. And that brings us to part B of this question. Find the distance. Oh, I'm just going to fill these into my diagram first. X is 45, and Y is about 44 to the nearest meter. Okay, so part B for our question, the distance from the point of projection after 3 seconds. That means the distance as the crow flies. As a straight line, which I'm drawing in my diagram here, what is the distance from where the particle started to where the particle finished? So I'm after this distance, direct distance from particle to finishing point, distance D. And hopefully it should be really obvious how to work this side. There is a right angle triangle I've just drawn. I'm after the longest side of the right angle triangle. This is a Pythagoras theorem question. Fingers crossed you got your answer before I've even finished this. So Pythagoras theorem is a squared plus b squared equals c squared, or in this case, vertical distance squared plus horizontal distance squared gives me the direct distance squared. And if you use your calculator, you should have about 63 meters to the nearest meter. And our final example on horizontal projection. A particle is again projected horizontally with a speed of u meters per second from a point 122.5 meters above a plane. The particle travels 90 meters in a horizontal direction. Find the initial speed of the particle. As before, start with a diagram. The only difference between this question and the previous ones is that we do not have the initial speed. We have to work it out. No prizes for guessing how to do it. I hope it's really obvious at this point. The diagrams aren't always necessary for the question, but they do help visualize exactly what is going on. Even if your question doesn't mention a diagram, I would still draw one in your test. It at least gives the examiner an idea that you know what you're doing. So here's our initial speed of u meters per second. And if you think about the path the particle is likely to follow, gravity will pull it down to the horizontal surface. And as before, I'm going to resolve vertically and horizontally using my Suvat equations. You don't have to look at vertical motion first. I just find it easiest to do so. So I'm going to take vertical motion downwards. If I look at my Suvat variables, SUV, AT, my distance down is 122.5 meters. My initial speed is 0. My final speed, I don't know what it is as before. If the question asks you to work out your final speed, it's very straightforward. Pick an appropriate Suvat equation and just do it. Acceleration due to gravity going downwards is 9.8. Again, that's because no other forces are acting on the particle. You're 9.8 meters per second. And time is t, because I don't know what it is. So if I do my Suvat equation, s equals ut plus half nt squared, I have 122.5 equals 0 plus a half times 9.8 times t squared. And if you can work backwards to find t, t is going to be plus or minus 5 seconds. Because we're looking at time, you cannot have negative time. You stick with your 5 seconds. Unfortunately, we don't know how to go backwards in time yet. Once we have our time is 5 seconds, we can work out the initial speed. I'm going to do that by resolving horizontally, taking motion to the right. And I got my arrow the right direction this time. So if I look at S, U, V, A, and T, I know my time is 5 seconds. I know my distance left and right is 90 meters. My initial speed is U, so I'm trying to work out. My final speed is V, because I don't care what it is. And my acceleration is 0, because it's not accelerating left or right. And again, if I use S equals ut plus half nt squared, the same equation again, I have 90 equals 5 times U plus 0. Hopefully 90 divided by 5 should give you 18 meters per second. And we have finished horizontal motion. I hope it's very easy for you.